Welcome back to the first lesson of week 7. In this lesson, we're going to look at what computational thinking is. So in this lesson, we'll look at all the aspects of computational thinking. We'll briefly review what we already know about computational thinking, and we'll look at some new things that we need to know because they could come up in the exam. So computational thinking is a general thinking skill that allows us to recognize the problem that needs to be solved and to develop suitable strategies to solve the problem. It is seen as a transferable skill so that getting good at solving computational problems by writing programs will help you to solve problems in other areas of academic study and life in general. We learned more about problem recognition in lesson 2.2, but basically that's where we identify a problem and decide that it is solvable by computational methods and that the number of steps is not infinite or intractable. Once we have identified that a problem is solvable by computational methods, we employ computational thinking to solve the problem. Computational thinking has 5 key features. It is abstract, logical, procedural or modular, we sometimes say. It's future focused and it can employ concurrent methods. So let's explore all of those in a little bit more detail. Lesson 2.1 is all about abstract thinking, so I'm not going to go into huge amounts of detail here. If you want to go back and look at that lesson, you can fill in all the gaps if there's anything you don't remember. You should be aware of the difference between an abstraction and reality, the reasons we use abstraction, and how we select the right details to create an abstract model. I'm not going to go into that now. Go back to week 2 if you can't remember. We also employ logical thinking, and we did quite a lot about that in week 3 when we did the fox and hen puzzle. So go back to that week if you want to refresh your memory about logical thinking. Logical thinking is how we create selection or branching structures in our program by using logical tests or Boolean expressions. We have to identify places in our problem where we need to make a decision. We have to define the decision. That's typically comparing 2 values using a relational operator, and that expression produces the value true or false. And then we have to decide what would happen if the expression is true or if the expression is false. And the structure that we mainly use in our programs would be if, else, and elif structures. The third aspect of computational thinking is procedural thinking, and we talked about that quite a lot in week 4. This involves decomposing a problem into smaller problems and creating reusable components such as functions and procedures. We reviewed the advantages and risks of decomposition, and we looked at some strategies for reducing the risks. For example, planning carefully and working as a team. Teamwork involves careful planning so that the task is planned properly before it is split up among the team. A good leader will help to allocate work and support all members of the team so they can complete the task. Good teamwork involves using standardized approaches, for example, using a standard way of defining variable names so that the different variables made by the different people in the team will work together. And we looked at some ways that we can limit risk, and a very key feature was to try to avoid the use of global variables. Anyway, go back to week 4 if you need to remind yourself about any of these points. We learned the difference between local and global variables and the risks of using global variables, and we looked at alternatives, We can pass parameters to our procedures and functions by reference or by value, and we can return values back to the main program. Now I want to introduce a new topic, which is thinking ahead. Thinking ahead is a strategy that programmers employ to reduce the stress and work of producing programs. Programmers who work carefully plan before they begin, and they aim to work smarter rather than harder. Wherever possible, they save code to reuse another time. This is the theme of reusable components, which we have discussed before. We write procedures, functions, and other modules once, and then we can use them many times in the same program or reuse them between different programs. The two main advantages are that this reduces the amount of work we have to do, and it makes our code more reliable because we're reusing previously tried and tested code. There are risks and issues. For instance, our code might not be perfectly suited to new tasks, and we can make our components reusable by using parameters and returned values, and by making our functions and procedures very abstract. That means removing the details and leaving just the bare bones of the code. And that way, our code will be as reusable as possible. Another topic that comes up when we're talking about planning for the future is designing our programs to use caching. A cache is a small temporary storage area, and data that the computer uses a lot is stored in fast access memory near to the processor. That makes our code run much more swiftly. The computer uses cache automatically. The operating system will be set up to use cache. We don't have to write special code in our programs to make use of it, but it could come up in an exam question. So let's briefly look at the three types of cache that they'd like you to know about. Page cache is where the computer stores the most frequently used data in a kind of buffer zone very close to the processor. Memoization is where the computer stores the results of frequently done calculations. That saves the computer having to do the working out again. And a web cache, you might be familiar with that. A web cache is where the computer stores a web page on your own computer the first time you open it, and then afterwards, unless you press refresh, it will just go back to the local copy. And the final type of computational thinking, which you need to know about to be ready for the exam, is thinking concurrently. This is quite a big topic, so there's an entire lesson about this, and that's lesson 7.2, which follows this one. For now, let's just briefly say that concurrency means that things happen at the same time. Some computers allow processing of different tasks to go on at the same time. And also, if we split our work between different members of the team, we can all be preparing different parts of the software at the same time. But much more about this in lesson 7.2. So, in this lesson, we've looked at abstract thinking, logical thinking, procedural thinking, thinking ahead, and we've briefly touched on concurrent thinking, which we'll deal with in more depth in the next video. So here's a task that I've set for you. Imagine that you had to write software to control a self-drive car. I'm not going to ask you to actually write that software at this stage, but I'd like you to write one paragraph about each type of computational thinking and how you would apply that as a strategy when you were writing the software for a self-drive car. And I'll take that in and we'll go through it in class.